Now, how to complete the problem? See, that is, we can calculate for one octant and use symmetry for the others. Okay. See, this is the one octant. There is a 45, 45, 90 degrees. That is the x comma y comma x. We can calculate x, y. Then we can find all the values. That is x comma y comma x, minus y comma x, minus x comma y, minus x minus y, x comma minus y, minus y minus x, y comma minus x. Okay, these are the octants. C. Setting decision parameter for finding the closest pixel to the circumferences and comparison of squares of the pixel separations distance avoid the square to the root calculations. So the circle function is defined f circle of x comma y equal to x square plus y square minus r square. Any point of x comma y satisfies the following condition, that is f circle of x comma y equal to less than 0 if x comma y, that is inside of the circle boundary, equal to 0, that is if x comma y is on the circle boundary, greater than 0 if x comma y is outside the circle boundary. See, the decision parameter is a circle function evaluated as pk equal to f circle of xk plus 1 comma yk minus 1 by 2, then xk plus 1 whole square plus yk minus 1 by 2 whole square minus r squared, then pk plus 1 equal to f circle of xk plus 1 comma yk plus 1 minus 1 by 2, then xk plus 1 whole square plus yk plus 1 minus 1 by 2 whole square minus r squared, then pk plus 1 equal to pk plus 2 of xk plus 1 plus yk plus 1 minus yk whole square minus of yk plus 1 minus yk plus 1. See, yk plus 1 equal to yk if pk less than 0 and yk plus 1 equal to yk minus 1 otherwise. Thus, pk plus 1 equal to pk plus 2k plus 1 plus 1 if pk less than 0, pk plus 1 equal to pk plus 2k plus 1 plus 1 minus 2yk plus 1, and also increment the value of 2k plus 1 and 2yk plus 1 that equal to 2xk plus 1 equal to 2xk plus 2, 2yk plus 1 equal to 2yk minus 2 if p greater than 0. At starting position of x naught comma y naught equal to, we can take 0 comma small r, 2x0 equal to 0 and 2y naught equal to 2r. Based upon that equation, these equations, we can calculate the values. Okay. See, initial decision parameter p naught equal to f circle of 1 comma r minus 1 by 2, that is 1 plus r minus 1 by 2 whole square minus r square, that is 5 by 4 minus r. For r specified as an integer, round p naught to p naught equal to 1 minus r, because of all the increments are the integers. In that way, we can assign p naught equal to 1 minus r because of all the values are the increment values. Okay, so all the increment values. See, algorithm. Input radius small r and circle center x naught comma xc comma yc, and obtain the first point on the circumference of a circle centered on the origin as x naught comma y naught equal to 0 comma r. Calculate the initial value of the decision parameter as p naught equal to 5 by 4 minus r. At each xk position, starting at k equal to 0, perform the following test. If pk less than 0, the next point along the circle centered on 0, 0 is xk plus 1, yk, and pk plus 1 equal to pk plus 2xk plus 1 plus 1. Otherwise, the next point along the circle is xk plus 1, yk minus 1, and pk plus 1 equal to pk plus 2xk plus 1 plus 1 minus 2yk plus 1, where 2xk plus 1 equal to 2xk plus 2 and 2yk plus 1 equal to 2yk minus 2. To determine the symmetry points in the other 7 components, move each calculated pixel position x, y onto the circular path and center on xc, yc, and plot the coordinate values x equal to x plus xc, y equal to y plus yc. Repeat step 3 through 5 until x greater than or equal to y. See, for example, given radius 10, use the point circle drawing algorithm to determine the pixel in the first quadrant. So p naught equal to 1 minus of that equal to minus 9, x naught comma y naught equal to 0 comma 10, 2 x naught equal to 0, 2 y naught equal to 20. Now calculate values k, pk, xk plus 1, yk plus 1, 2xk plus 1, 2yk plus 1. That is 0, minus 9, 1 comma 10, 2, 20, 1, minus 6, 2 comma 10, 4, 20, 2 minus 1, 3 comma 10, 6, 20, 3, 6, 4 comma 9, 8, 18, 4 minus 3, 5 comma 9, 10, 18, 5, 8, 6 comma 8, 12, 16, 6, 5, 7 comma 7, 14 comma 14. Okay. So this is only one octant value. Based upon that, we can create all the octant values. See here. We can only find this one. Then based upon that, we can find this one, then this one, then this one. Okay. Then we can draw the circle likewise. So these are the only one octant values. So this is the one octant circle. So now 110. That is the next 10 comma 1, 10 comma 2, 10 comma 3, 9 comma 4, 9 comma 5, 8 comma 6, 7 comma 7. Then next minus 110, minus 210, minus 310, minus 4 9, minus 5 9, minus 6 8, minus 7 7. Next 1 minus y comma x comma y. Minus 110, minus 210, minus 310, minus 4 9, minus 5 9, minus 6 8. Then 10 comma minus 1, 10 comma minus 2, 10 comma minus 3, 9 comma minus 4, 9 minus 5, 8 minus 6, 7 minus 7. So likewise we have to x comma y comma x, x minus y minus x minus x minus 5, minus 5 minus x, minus x, y minus x minus y. Likewise we have to take all the values. Then we can produce the circle. For example, so digitize a circle called x minus 2 whole square plus y minus 3 whole square equal to 25 in the first quadrant. Then p naught equal to 1 minus r equal to minus 4, x naught comma y naught equal to 0 comma 5, 2 x naught equal to 0, 2 y naught equal to 10. You can find the, in this equation we can find the x comma y, then produce the x and y value. Okay. R square, this is a 25, r square equal to, that is r equal to 5, then 1 minus r equal to minus 4. Okay. So now we can get these values 1 5 2 5 3 4 4 3. Based upon that we can find all the values x comma y, y comma x, x minus y, y minus x likewise. Okay, then we can draw the circles. See, these are the right values: x1 minus xy minus x minus y, x minus y, y comma x, y comma minus x, minus y minus x, minus y x. Okay. So finally, we can draw the circle likewise. Now, from the ellipse generating algorithm, there is equation that is it is called as an ellipse. This is an ellipse. So d1 plus d2 equal to constant, then f1 to x1 comma y1, f2 to x2 comma y2, then root of x minus x1 whole square plus y minus y1 whole square plus root of x minus x2 whole square plus y minus y2 whole square is constant. The general equation is ax square plus by square plus cxy plus dx plus ey plus f equal to 0. Simplified form x minus xc by rx whole square plus y minus yc by ry whole square equal to 1. In polar coordinate x equal to xc plus rx cos theta, y equal to yc plus ry sin theta. In ellipse function, f ellipse of x comma y equal to ry square x square plus rx square y square minus rx square ry square. If ellipse of x comma y less than 0, if x comma y is inside the ellipse boundary equal to 0, is on the ellipse boundary greater than 0 is outside of the ellipse boundary. From ellipse tangent slope dy by dx equal to minus 2 r y square x by 2 r square y. At boundary of region equal to minus 1, 2 r y square x equal to 2 r x square y. Start from 0, r y. Take x sample to boundary between 1 and 2. Switch to sample y from boundary between 1 and 2. That is 2 r y square x greater than equal to 2 r x square y. So here we can take the 4 quadrants, and for each quadrant we can assign the two regions. Now we can find the region 1, region 2, then we can, based upon that, we can find the remaining of the quadrants, then we can produce the ellipse. See, in the region 1, P1k equal to f ellipse of xk plus 1 comma yk minus 1 by 2 ry square of xk plus 1 whole square plus rx square of yk minus 1 by 2 whole square minus rx square ry square. For next sample, P1k plus 1 equal to f ellipse of xk plus 1 plus 1 comma yk plus 1 minus 1 by 2 ry square of xk plus 1 whole square plus rx square yk plus 1 minus 1 by 2 whole square minus rx square ry square. Pk plus 1 equal to p1k plus 2 ry square of xk plus 1 plus ry square plus rx square of yk plus 1 minus 1 by 2 whole square minus yk minus 1 by 2 whole square. This increment, that is 2 ry square xk plus 1 upon r square 2 ry square xk plus 1 plus ry square minus 2 r square 2 rx square yk plus 1. That is if p1k less than 0 or pk greater than 0. For increment calculation of initially 2 r square x equal to 0, 2 rx square y equal to 2 rx x square ry. So update x by adding 2 ry square to the first equation and update y by subtracting 2 rx square to the second equation. So for that initial value p1 not equal to f ellipse of 1 comma r y minus 1 by 2, that is r y square plus r x square of r y minus 1 by 2 whole square minus r x square r y square, then p1 not equal to r y square minus r x square r y plus 1 by 4 r x square. Okay, here we can take this one, this quadrant, find this quadrant, then automatically we can find these three quadrants. But in this each quadrant will assign to the two regions. Based upon these, to find the two regions, we can calculate the remaining of the coordinate values. Then we can find the ellipse. In the region 2, P2k equal to f ellipse of xk plus 1 by 2 comma yk minus 1 r by square of xk plus 1 by 2 whole square plus rx square of yk minus 1 whole square minus rx square ry square. For an example, P2k plus 1 equal to f ellipse of xk plus 1 plus 1 by 2 comma yk plus 1 minus 1 for ry square of xk plus 1 plus 1 by 2 whole square plus rx square of yk minus 1 whole square minus rx square ry square. Then P2k plus 1 equal to P2k plus 2 rx square of yk minus 1 plus rx square plus ry square of xk plus 1 plus 1 by 2 whole square minus of xk minus 1 by 2 whole square. Initially P20 equal to f ellipse of x0 plus 1 by 2 comma y0 minus 1 P20 f y square x0 1 by 2 whole square plus rx square y minus 1 whole square minus rx square ry square. So here for simplification of the calculation, P20 can be done by selecting the pixel positions in the counterclockwise, clockwise, anti-clockwise, clockwise. Coordinate values are x comma 0 and unit samples to positive y direction until the boundary between two origins. So first we have to find only one boundary, then we can find that we can calculate all the values of the particular ellipse. Next algorithm. So input rx comma ry and the ellipse center xc comma yc and obtain the first point on an ellipse centered on the origin as x0 y0 equal to 0 comma ry. Calculate the initial value of the decision parameter in region 1 as p1 not equal to ry square minus rx square ry plus 1 by 4 rx square. At each xk position in region 1 starting at k equal to 0, perform the following test. If p1k less than 0, the next point along the ellipse centered on the 0 comma 0 is xk plus 1 comma yk and p1k plus 1 equal to p1k plus 2 ry square xk plus 1 r square. Otherwise, the next point along the ellipse is xk plus 1 comma yk minus 1 and p1k plus 1 equal to p1k plus 2 ry square xk plus 1 minus 2 rx square yk plus 1 plus r square. 2 ry square xk plus 1 equal to 2 ry square xk plus 2 r square 2 rx square yk plus 1 equal to 2 rx square yk minus 2 rx square. And continue the 2 ry square x greater than equal to 2 rx square y. So when we have can end of the particular values based upon these condition, that is 2r by square r by square x greater than equal to 2rx square by n, this condition is satisfied, we can stop the calculation of the particular ellipse values. Okay, so calculate the initial value of decision parameter in region 2 using at last point x0 y0. So whenever region 1 of the last point is there, that value will be taken as the first value of the region 2, that is p2 0 equal to r y square of x0 plus 1 by 2 whole square plus rx square of y0 minus 1 whole square minus rx square ry square. At each like position in region 2 starting at k equal to 0, perform the following test. If p2k greater than 0, the next point along the ellipse centered on 0, 0 is xk, yk minus 1, and p2k plus 1 equal to p2k minus 2 rx square yk plus 1 plus rx square. Otherwise, the next point along the ellipse xk plus 1, yk minus 1, and p2k plus 1 equal to p2k plus 2 ry square xk plus 1 minus 2 rx square yk plus 1 plus rx square, using the same incremental calculation for x and y in the region 1. So determine the symmetric points of other three quadrants. Okay, so first we have only one quadrant, then symmetric of the three, that is a minus xy, minus x minus y, minus x comma minus y. Move each calculated pixel position x comma y onto the elliptical path centered on xc comma yc, and plot the coordinate values x equal to x plus xc, y equal to y plus yc. Repeat this step until region 1, that is 2ry square x greater than equal to 2rx square y. But here, whenever I go from the second region, when it will be any one of the x naught comma y naught 0, then we can stop the process and we can draw the ellipse. Okay. In the first region, the condition is 2ry square x greater than equal to 2rx square y. But whenever they go from the region 2, this or any one of the x naught equals 0, then we can stop the process. Next, for example, display the ellipse with the parameter rx equal to 8 and ry equal to 6 in the first quadrant. That is 2ry square x equal to 0 with increment 72, 2rx square equal to increment minus 128, then p1 not equal to ry square minus rx square ry plus 1 by 4 rx square, that equal to minus 332. So based upon that, we can calculate values. K equal to 0, 32, 1 comma 6, R is equal to 72, 768, minus 224, 2 comma 6, 144, 768, minus 44, 3 comma 6, 216, 768, 208, 4 comma 5, 3, 288, 640, minus 108, 5 comma 5, 360, 640, 288, 6 comma 4, 432, 512, and 244 7 comma 3504 there. But here see, the last value of the region 1 is 2ry square xk plus 1 greater than or equal to 2rx square yk plus 1. In that we can start the particular process. Okay, now we can go for the region 2. For region 2, the initial point, this is 7 comma 3. Here see, this is the first point of the initial point of the region 2. And the initial decision parameter is p20 equal to f of 7 plus 1 by 2 comma minus 51. C. K p2k xk plus 1 yk plus 1 2 ry square xk plus 1 2 rx square yk plus 1. Now minus 151 8 comma 2 576 258. Next 1 233 8 comma 1 576 128 and 2 745 8 comma 0. When x comma y any one of the 0, we can stop the process. We can stop the calculations of the particular region 2, then we can take the region 1 region 2 values, then it will be assigned to the particular symmetric values x comma y, that is x minus y minus x minus y y comma minus x, then we can define the particular ellipse. See, this is one part of the area. Likewise, we have got the remaining three quadrants, then we can get the ellipse. Okay. Next, filled area primitives. See, but there are the two basic approaches for area filling. First one is by determining overlap intervals for scan lines, and second one start from given interior position and filling the outwards. These main two basic approach for area filling. First one is by determining overlap intervals for scan lines. Next, start from given interior positions and filling the outwards. Next. So, for example, first one is scanline polygon fill algorithm. Intersection points of scanline with the polygon edge are calculated, and points are stored from left to right, and corresponding the frame buffer position between each intersection pair are set by specified color. See here, you can define the specified color from the two intersection points. Okay, so a corresponding frame buffer position between each intersection pair are set by the particular specified of the colors. Okay. A scanline pass through vertex intersects two polygon edges, that is the one scanline and second scanlines. Okay, scanline Y intersect two even number of edges. Two pair of intersection points correctly find the interior span. Scanline Y intersect an odd number of edges. Must count the vertex intersection as only one point. And scanline Y intersecting edges are now on the opposite side, and Y intersecting edges are on the same side. By tracing around the boundary, if the endpoint Y values of two consecutive edges monotonically increase or decrease, count middle vertex of a particular single value. While crossing non-horizontal edges in the clockwise, check each edge whether the edge and next edges have either monotonically increased or decreasing of the endpoints. So likewise, we have the short end. Likewise, this is the this one. When I go from this, you can take this one. This is the scan line y plus 1, scan line y minus 1. Okay, so and you can see each and every whether the edge or next edge have the either monotonically increase or decreasing of the points. Okay, based upon that, we can implement the scan line algorithms. Okay. So span coherence, all pixels on the span are set to the same value. Scan line coherence, consecutive scan lines are identical. Edge coherence, edge intersected by scan line I are also intersected by scan line I plus 1. Based upon that, we can perform the operations. So in determining the edge intersection, we can set up incremental setup calculations using fact that slope of the edge is constant. So scan line yk plus 1 y, that two consecutive, these are two consecutive scan lines or intersecting the polygon boundaries. Okay, so the slope of this polygon boundary line can be expressed in terms of scanline intersection coordinate m equal to yk plus 1 minus yk by xk plus 1 xk. That is change the between the school line coordinate value is 1, yk plus 1 yk equal to 1. The x intersection value xk plus 1 on the upper scan line can be determined from the x intersection value xk on the preceding scan lines. Xk plus 1 equal to xk plus 1 by m. So each successive x-intercept can thus be calculated by adding the inverse of the slope and arriving the nearest integer, recalling the slope of the two integers m equal to delta y by delta x. Then delta x and delta y, based upon difference, we can find the edge point, that is xk plus 1 equal to xk plus delta x by delta y. Then odd even rule, odd edges means interior, non-zero binding number means interiors. These are exterior, interior, odd even, and then odd values. Okay, thank you.